Hi friends, in previous topic we have discussed Newton's second law. Newton's second law gives us a relation between force and acceleration. It simply indicates that the acceleration is produced by force. But then, from where this force arises? Which agency exerts the force? And this was answered by Newton's third law. It is 5.7 Newton's third law. Impulsive force is also a part of Newton's second law. That is, we have discussed in 5.6. Now, the force produces acceleration. It was explained by second law. But then from where the force arises? What is the agency which exerts the force? And the answer is very simple. The body exerts force on another body. It means that one body exerts force on other body. Consider two objects. Object is A. Object is B. When it is coming and colliding on B, A on B, it means that A exerts force on B. So the force is always exerted by one body on other. Now this is interaction is origin of the force. Two examples. Some examples are given in book. That is, there is a spring. Suppose we consider a spring. If you press this spring with hand, if I press it, then we feel that the spring is also exerting force on our hand. It means that when we apply force on the spring, our hand is exerting force on the spring. Simultaneously, spring is also exerting force on our hand. Here, the force by spring is physically felt by us or our hand. Another example, this is suppose earth and this is a small stone. We all know that once the stone is released from certain height, it is pulled towards the earth. Means earth is attracting it. The question asked by Newton was that whether the stone is also attracting the earth, whether the pull is exerted by the stone on the earth, and the answer is yes. Not only earth pulls the stone in downward direction, but this small stone is also attracting earth towards itself. Only thing is that this one is not visible. The pull by the stone on the earth is not visible. It is invisible case, or it's a very small, therefore also not felt. But whenever the force arises, it is because of interaction of two objects, two bodies. And Newton came up with a very beautiful statement that is called as the Newton's third law. And you all know this one. Action and reaction are equal and opposite. It's a very crisp statement given by Newton, and it became a part of common language. And because of this one, there are certain misunderstandings or misconceptions developed in case of Newton's third law. Action and reaction are equal and opposite, and I haven't seen or found a single person on this earth who does not know this law. The time they start understanding it, they all know that action and reaction is equal and opposite. But in fact, this is not it is a complete one, but then which gives some misconception. We can write it in more simple way. Newton's third law can be stated as the force always arise, or forces always arise in pair. They are not single. They always arise in pairs. For example, force exerted by A or exerted on A by B is equal and opposite. Is equal and opposite to the force exerted on B by E. This becomes a more simple and clear statement of Newton's third law. Force always arises in pairs. Force exerted on A by B is equal and opposite to the force exerted on B by E. It becomes more clear statement which removes misconception in this law. There are certain points related to this one. These points are following, which are actually misconceptions. See that A and B, the forces are because of interreaction. It never comes alone. Force by A. So first point is that force arises because of interaction. Single body, one body can never experience force or it can never exert force. Second point in that one, as, not second, first one, let us see. Action and reaction, these are two separate names. But even though the names are used separately, action is also force and reaction is also force. So two different names for the same quantity. So once again I say action is force and reaction is also force. Second thing, action, there is a second misconception that action comes first. Action first and then reaction. This is also not correct. It is considered, we can, from statement of this law, we think that action is cause and reaction is effect, but that is not true. Newton's third law never encounters cause and effect. Action and reaction, both of them happen simultaneously at the same instant. It is not that action comes first and then reaction. This is also misunderstanding. Action and reaction, both of them act simultaneously. Third one, see that there are two bodies, body A, body B, they interact. Now in this one, force on A by B is equal to force on B by E. On A by B, on B by E. So force on A by B is equal and opposite to that of the force on B by E. Now these two forces, even though they are acting at the same instance, at the same time, they are acting on two separate bodies. Therefore, it is meaningless to add them. If you add them, this one, as they are equal, this is meaningless because they are not acting on the same body. They are acting on two different bodies. So it is wrong. It is meaningless. Adding them and showing that force is 0, therefore acceleration will be 0. Not correct. Whenever we are trying to find out acceleration on A, then we need to consider force on A alone. Whenever we are trying to find out acceleration on B, we need to consider force on B alone. But this situation, it is true when we are taking internal forces. Any object which is, in case of internal forces I am talking about. This is one particle, this is second particle. There is a force on this by this and then equal and opposite force. So these internal forces, they cancel out in pairs. And when we go on seeing all the forces inside the body, all internal forces, some of them become zero. Inside the body, action and reaction force, they cancel out each other in pairs, thereby net internal force is zero. And because of this one, applying Newton's second law at center of mass is possible. So this is a very beautiful thing, that without bothering all internal forces inside the body, we are applying Newton's second law by considering that the whole mass is concentrated at one point, which is known as center of mass. These all are the details about this Newton's third law. Let us discuss solve problem from the book. That is, I read this problem first. It is solved problem 5.5. You can refer the book also. Two identical, it's a 5.5. It is two identical billiard balls strike a rigid wall with the same speed but at different angles and get reflected without any change in speed as shown in figure. What is A, direction of the force on the wall due to each ball? B, the ratio of the magnitude of impulses imparted to the balls by the wall. Two parts it is. Let us first take first part. This is problem 5.5, solved problem from book. It is solved problem 5.5. First case 1. This is ball, this is wall there. Ball is going in this direction and it is turning back. Let m is mass of the ball, m is mass, u initial velocity. After bouncing from the wall, mass remains same, and then final velocity. No change in magnitude, but direction is reverse. There is a reversal of direction, so it becomes minus. Impulse is asked. What is the impulse in this one? Impulse is nothing but it's a change in momentum. So P initial. This is only on x-axis. So when we are considering two axes, we need to consider, as it is moving along x-axis, P initial along x is equal to mu. It is P final along x-axis is equal to minus mu. P initial along y-axis is 0. No component of velocity. P final along y-axis is equal to 0. No component of velocity along y. Therefore, delta P along x-axis is equal to P final, P initial, minus mu, which is equal to minus 2mu. Delta P along y-axis is equal to 0 minus 0, which is 0. So change in momentum is impulse, and that is minus 2mu here. It's going. So final was opposite, it's a bouncing back. But the direction of this impulse is a perpendicular to the wall. It is a normal to the wall. Its impulse is perpendicular to the wall. normal to the wall. It's perpendicular means normal to the wall. Change is minus 2 mu. Magnitude-wise change is 2 mu. This is the first situation which is mentioned here. Now let us take second situation. What is the second situation? In second case, case 2. This is x, this is y, and then ball is coming in this direction. Initially, it is u. Now this one, I can just, if it is coming in this direction, this is a vector. It can be combination of this vector plus this vector. If it is u, this angle is theta, then it becomes minus u sine theta, downward. And this one will become as u cos theta plus u cos theta. So u I can, when it is coming in this way, I can resolve it like this. So P initial along x axis is equal to mu cos theta. P initial along y axis is minus mu sin theta. Where it is like this. It's here and then it's here, positive direction. Now another case is, it is in this one. It is in this direction. This is also, I can, this plus this. So it is minus u sin theta, no problem. But this becomes minus u cos theta. This one becomes, this remains here, but it's a changing its direction. So along x, it becomes minus u. So P, it's a reflection in this way. When it is reflecting in this way, it's down plus u. So P final along x is equal to minus mu cos theta. P final along y is equal to minus mu sin theta. Impulse along x, I along x is equal to minus mu cos theta. It is I along x is delta p along x. Impulse is nothing but changing momentum, which is equal to p final along x minus p initial along x, which is equal to minus mu cos theta minus mu cos theta, which becomes minus 2 mu cos theta. But impulse along y direction, impulse along y direction is equal to change in momentum along y, which is py final minus py initial minus mu sin theta plus this minus will become plus mu sin theta. Therefore, impulse along y direction is 0. So total impulse in this case is, so no impulse along y direction. Impulse is only along x direction. It means it is perpendicular to the wall. Again, change in momentum is perpendicular to the wall or normal to the wall. One more part is asked there, ratio of impulse in first case to the second case. So ratio is, first one, impulse of first case is mu to mu. Both are minus. Divided by impulse 1, impulse 2, 2 mu cos theta. Theta is 30, which becomes 1 by cos 30, which is nothing but 1 by root 3 by 2, which is equal to 2 by root 3. This is the ratio of impulse in case of second one. Thank you.